Okay, hello, good evening, everyone. Or should I say afternoon? Okay, yes, Natalie, hello. Welcome back to our March week 4. Okay, so happy Wednesday, everyone. All right, so finally today we are going into a new chapter. Okay, so today we are in chapter 4. So my progress is a bit slow compared to other teachers because they are in chapter 4 last week already. All right, but hey, no rush lah, because trust me, we have plenty of time, okay, because I believe it would be quite a while, before you go for SPM, okay. But then again, SPM is still pretty far lah. SPM will be, I don't know, next year, okay. So, Lipin, hello. 怎么你会来 join 我的 English class 的 Anyway, so chapter 4 so please get ready. I know some of you, okay, if you're from other tutors class, maybe they have gone through this already. Okay, I'm sorry, mine is a bit slow. Okay, anyway, so today we are talking about chapter 4, which is rate of reaction. Okay, rate of reaction, or BM is called Kadar Tindak Balas. All right, this is 晚上不能OK， 不用紧 ，make sure 你会听英文Anyway, so I would say this is one of the hard chapter of your Form 5. Okay, your Form 5 has 2 or 3, I would say, harder than usual chapter. Okay, so if this chapter you have some problem understanding it it's actually okay, because you know why? This chapter, it comes from chemistry. That means during the old times, last time this chapter doesn't exist. Okay, so suddenly the government say, you know what, let's let your science student learn this chapter, so they pull it down from chemistry. So the last year's Form 5, they learned this the first time last year. So now you guys are the second batch lah. So anyway, let us get ready and let us go into it. Today I'll try to go into something simple first, and next week maybe we have the time, then we will go to graph. I don't think today we can go to graph. Oh yeah, the worst part about this chapter is you have to draw this stupid graph. Okay, not to mention not only you need to draw the graph, you need to draw this stupid tangent line. Okay, which is a major pain in the butt, because this thing, trust me, there's a lot of work to do one. Yeah, so many calculation. So this is actually just like your normal mathematics. I don't know about in mathematics do you draw curve line and calculate the tangent? You know what's a tangent? Tangent is a line that only touches a curve at one point. So you need to draw that tangent line, and you need to calculate the, what was the thing again? The gradient, yes, okay, the gradient. So this one later lah, okay? So Natalie, don't scare yourself first, it's okay. We shall go into that later. Okay, come on, step by step. So what is rate of reaction? Okay, rate means how fast. Okay, rate means how fast. If you do something at a very high rate, that means you do it very fast. If you do something at a very low rate, that means you're very slow lah. Okay, so rate is something like a speed. So you can call this thing sort of like speed of reaction. Or you can say how fast a reaction is. Some reactions, okay, so what is reaction? Of course, we are talking about chemical reaction. All right, so we have millions of chemical reactions in this world, but of course, some reactions, they are very slow. Like rusting is very slow. Rusting takes years to rust, so very slow. But some reactions, they are very fast, like explosion. Okay, boom, no more. Okay, in few seconds, they are done. So you have fast and slow reaction. All right, so let's talk about fast and slow reaction in life. Okay, so this is the basic. Let's talk about the basic first. Okay, so a chemical reaction is a process in which one or more reactants are converted to one or more product. Okay, what does it mean? What is reactant and product? Okay, to put it in Mandarin, reactant means 原料. Okay, the original thing. Okay, and product means the 成品, the final product. Okay, for example, if you're making cake, okay, I'm not a baker lah. I don't know how to make a cake. Okay, so I'm sure you need flour. Okay, you need egg, you need butter, Okay, and then after some magic later, oh, sugar, sorry. Okay, and of course, after some magic later, this thing turns into a cake. All right, so this is the reactant. Okay, so you put them together, you let them have chemical reaction with each other, and they will turn into a cake. So your cake is a product lah. Okay, very simple. But of course, we don't learn this lah. This is not we are not doing cooking class right now. Okay, so let me give you a very typical example. Okay, you learn in Form 1 what is respiration, right? Okay, you know what is respiration, right? 呼吸 respiration. Okay, so respiration, we know that you need oxygen and you need glucose. Okay, you need oxygen and need glucose. So you mix them together, you will get carbon dioxide and water. And of course, energy lah. And of course, energy. So oxygen and glucose is the reactant. And then carbon dioxide and water is the product. Right, okay, so the thing in the middle, what's happening here is the chemical reaction, 化学反应. So this reaction, this 化学反应, will change these two into these two. So reactant and product law. Okay, so very simple stuff here lah. Okay, this one is very, very common sense stuff. Okay, so a chemical reaction is a process in which one or more reactants are converted to one or more products. So reactant could be 1 or 2 or 3 or 4, and then product is the same thing, 1 or 2 or 3 or 4. So like this lah. Okay, you have like 4 reactants here. Sorry lah, I don't bake lah. I don't know what you need to make a cake. Okay, I'm sure you need flour, I guess. Okay, you need egg, you need butter, you need sugar. I don't know what cake you are making. I'm just assuming. Okay, so at the end you get a cake. So this is your product. So you have 4 reactants here turning into a product. Shitty example, I know. Okay, but as long as you get the point. All right, so let's take for example here. Okay, can you see lead nitrate and potassium iodide? Okay, after chemical reaction, they turn into lead iodide and potassium nitrate. You may say, yeah, sir, what is this? What is this? Okay, if you don't know, it's okay. Because this thing, you want me to explain, I also don't know how to explain. Because for us who learn chemistry, okay, I've taught chemistry for 10 years. This thing is like a very basic reaction. But for you, this is like, I'm like speaking Spanish to you right now. I'm like speaking Tamil to you. You're like, I don't understand. Okay, so it's okay. But by the way, this thing, what you will see here is this thing has no color. Okay, colorless. This lead nitrate is no color. So this potassium iodide also no color. But this lead iodide, it's yellow. It's yellow. And then this potassium nitrate also no color one. So from two substance that has no color, suddenly it changes into something yellow. Oh, when you see yellow, yes, the chemical reaction happened. That's all. Okay, that's all. So this one you don't need to know. Okay, it's a very complicated example. Why got 2 here? This one you don't need to know. All right. So for this chapter, I'm trying to keep it as simple as possible. You're not a chemistry student. You don't need to go crazy and learn all these, crazy reactions. Okay, you don't. Okay, so we are keeping everything simple. Okay, so anyway, from what we see here, from a chemical reaction, okay, let's come back to this chemical reaction. Okay, as time goes on, okay, reaction takes time, right? Reaction takes time, right? Some are slow and some are fast, like I said. So, but we know that as time goes on, okay, 时间一直在走的话，we know that reactant will eventually decrease, and then product will eventually increase, right? Okay, so that means that, okay, for example, you have oxygen and glucose in your body right now, right? But after 3-4 hours, the oxygen will decrease, the glucose will decrease. So you need to eat, but at the end, carbon dioxide and water will increase. This is why you keep producing carbon dioxide, you keep producing water. So a chemical reaction, in a chemical reaction, reactant will slowly decrease or quickly decrease. Okay, the point is they will decrease. Okay, 你的原料会下降, and of course the product, excuse me, the product will increase, right? Because all these reactant, they are converted into product. 它转换了, so your reactant will decrease, your product will increase. Common sense, right? When you are making your cake, so while the process of making the cake, this flour, sugar, egg, and butter, they will decrease. You don't see them anymore. But when the cake is done, or the cake increase law. Like I said, it's a shitty example, but you get the point. Okay, so if you look at this graph, okay, if you look at this graph, as you see, as time goes on, okay, 5, 10, 15 minutes, the reactant will decrease. Okay, the reactant will decrease. And as time goes on, 5, 10, 15 minutes, the product will increase. Okay, you are getting less and less reactant. You are getting more and more product. Right, you are using more and more glucose. You are creating more and more carbon dioxide. Makes sense, isn't it? 你一直在把 reactant 转去 product. So that's why reactant decrease law, product increase law. Okay, so one of the example I can give you is your car. Your car, you put petrol in your car, right? Petrol is the reactant. As you drive and drive and drive, the petrol gets less, right? Okay, then reactant decrease lah. And as you drive more and more and more, you keep producing more exhaust, more exhaust. The exhaust is carbon dioxide, so the reactant increase. Okay, very simple concept. Okay, please take note of this graph. Why is this not straight line? You might say, sir, why decrease not straight line? Why increase not straight line? Because you see, can you see the line is getting flatter and flatter? Can you see this line is getting flatter and flatter? It's getting slower and slower. Why? Because you see, any reaction, it's very fast in the beginning, right? 什么化学反应开始是最快的 okay? Very fast in the beginning, and then towards the end, they will slow down. They will slow down. Any reaction is like this. Okay, have you played firecracker before? You got see firecracker before? And the beginning, wow, you can see the fire burning here and there, very happening, a lot of fire, a lot of lights on. And then towards the end, when your firework is going to finish, the thing will kind of slow down, and at the end is no more. So same thing lah. So reaction, they changes over time. Okay, that they changes over time. That means you don't get a steady straight line down or a steady straight line up. They will be very fast in the beginning, and then eventually they will slow down. Okay, eventually they will slow down. Okay, so as you can see, the reaction is very fast here. Okay, because very steep Okay, 很斜, very steep. Okay, I'll talk about the gradient later. Okay, I'll talk about the gradient later. This chapter, you will see the word gradient a lot. You don't tell me you forgot what is gradient. Okay, I will kick you back to maths. Okay, y equals to mx plus c. If you don't know what is gradient, unforgivable. Okay, it's like you telling me, sir, I don't know what is pi. Okay, if you don't know what is pi, I worry about you. Okay, how are you going to pass your maths in SPM? Seriously. So you know what is gradient? Gradient is your 斜度, how steep something is. So the steeper okay, just to tell you here, the steeper the gradient, okay, that means more steep, the faster the reaction. Can you see this gradient here, very steep? You imagine this is a roller coaster. If you are here, wow, very steep. That means the reaction is very fast in the beginning. And then towards the end, gradient here is 0. You see, flat line already. So now the gradient is 0. The rate of reaction is, there's no more reaction here because the reaction stopped already. Right. So like I said, you just think of a firework. At the beginning, very happening, very bright, very colorful, very loud and everything. And then towards the end, the thing just kind of slow down and becoming, not happening really. It's becoming lame. Okay, nothing to see. All right. So quantity of reactant decrease. Okay, quantity of product increase. Okay, so you don't care about the graph actually. Okay, you only need to know how to draw them. Okay, anyway, so let's look at the two types of reaction. Of course, like I told you just now, we have fast and slow reaction. Okay, tindak balas laju and tindak balas perlahan. Okay, something that takes a short time to do and something that takes a long time to do. Okay, remember just now I said gradient, right? Gradient, right? So the steeper the gradient, okay, the steeper the gradient, the faster the reaction. Okay, 东西越斜反应越快. Okay, so again, steeper the gradient, faster the reaction. So if my graph is very steep, can you see there are two lines here? If you are taking, okay, like I said, imagine they are roller coaster. If you are on the blue line, wow, can you see this thing is very steep, 很斜. That means this is a fast reaction because very steep 很斜 okay, very steep Kecerunan yang tinggi. So that means the reaction very fast lor. Okay, whereas slow reaction, okay, the gradient is very small, very flat line. So the reaction is very slow. Okay, if your reaction looks like this, you know this is even slower lah, because you see very long time to finish. Whereas this one, the blue line like done. Okay, in a very short time, the thing is done. Very fast. Okay, so as you can see here, the blue line is a fast reaction. Okay, quantity of product increase quickly, whereas the red line, slow reaction, because the quantity of product increase slowly. Okay, this is very slow. Okay, very basic and fundamental to understand. Okay, nothing difficult yet. Today is just the appetizer. Next week, when the main course comes in, is when you start to scream for help. Like, ayo, sir, can I don't learn this? Okay, so I'm not going to torture you today, okay, since we have plenty of time. Okay, anyway, so what are the similarities? Okay, what's the similarity between fast and slow reaction? Okay, similarly, both the reactant will decrease. Okay, I don't care whether you are slow or fast reaction, reactant will decrease and the product will increase. Okay, easy, right? Okay, the reactor will become less, the product will become more. So what's the difference? Okay, what are the differences? Of course, number one, rate, that means how fast. Okay, how fast? For fast reaction, the rate of reaction is high. Okay, very fast. Okay, it happens in, okay, the next point related to it, it happens in a short time. The shorter the time, the faster the reaction. Okay, for example, let's talk about combustion. Wait. You know what? Let's finish slow reaction first. Okay, so rate of reaction in slow reaction, they are low. Okay, because it takes a long time to do. Okay, let's compare combustion and explosion. You know it's combustion, right? Combustion is when you burn something lah. Okay, let's say you take a piece of paper, you burn it. You take petrol, your car will do combustion. You know that? Do you know that? You put petrol in your car, your engine will burn the petrol so that your car can run. So that is combustion lah. 燃烧, pembakaran. You are burning something. Okay, so you see, combustion is burning something. Do you know explosion is the same thing? They are both burning something. They are both burning fuel. You know what is fuel? Fuel is the bahan api, 那个燃料. Okay, so both they burn something. But which do you think is going to hurt you? If you want to kill someone, would you use combustion or explosion? Very obvious, right? Okay, so that's why when they're fighting in a war, okay, they use bomb because bomb is explosion. But you might say, sir, how come so different one? Combustion cannot kill someone, but how come explosion can? Because explosion is just a faster version of combustion. Okay, you see, when you burn a piece of paper, how long does it take? Okay, one piece of paper maybe takes like, I don't know, 20 seconds, 20 to 30 seconds. Okay lah, consider quite fast lah. But compared to explosion, explosion is much faster. Hey, explosion doesn't wait 20 seconds like boom. No, okay, explosion is like boom. Okay, explosion sometimes is less than 1 second. Very, very fast. Okay, so like I said, explosion is just a faster version of combustion. Okay, it has a much higher rate and it takes a much shorter time. So you release energy. Okay, combustion release energy in a very long time, very slow. Explosion release energy in a very short time, very fast. This is how it kills people. Okay, too much of energy in a short time can kill someone. This is why if you drive and you bang into a wall, you will die on the spot. Why? Because suddenly you slow down, the energy is all transferred to you. Without airbag and without seatbelt, you will die. Okay, so because too much energy in a very short time, so you will die. But that one is physics already. I'm not going to explain. Okay, so you get the point. So fast reaction, it happens in a short time, very high rate, very, very fast. Slow reaction, it happens in a low rate, very slow, takes a long time. Okay, so that's all I'm trying to say. Okay, let's look at the example. Okay, this one very simple. So what is a fast reaction? So fast reaction, okay, whether something is fast or slow, guys, it is very subjective. For you, maybe burning is fast, but for some people, burning is slow. But generally, we are using very extreme example here. So for example, burning, like I said just now, combustion. Combustion takes around like, I don't know, 20, 30 seconds. So they are still considered fast. So we put them under fast reaction. Okay, what is precipitation? Precipitation in Mandarin is called 结晶. Okay, 结晶. Okay, what does it mean? That means you form salt. Sometimes when you add one chemical substance and another chemical substance, you add them together, you will start to see salt coming out. In the water, in the solution, you will see salt at the bottom. Okay, 结晶啦. So the process of forming salt is called precipitation. Okay, what is it called in BM? Pemendakan. Okay, I think it's called pemendakan. My BM is not too sure. If I'm wrong, correct me on that. Okay, so next, frying an egg. Okay, frying an egg takes like what? When you crack an egg onto a pan, how long does it take? 30 seconds to 1 minute. Roughly lah, so still quite fast. Okay, next, acid-base reaction. You might say, oh, I'm sure you recognize acid. Hey, what is base leh? Base is actually alkaline lah. What is acid-base reaction? Basically, that's your neutralization lah. Okay, you know it's neutralization. 综合, when you add acid and alkaline together, they become neutral. So that is neutralization. Like you brushing your teeth lah. Every morning your mouth is acidic. So when you brush your teeth with alkaline toothpaste, your mouth turns neutral. So it is a very fast reaction. How long do you brush your teeth? Maybe, I don't know, 1 to 2 minutes. Very fast. And then next, soap and detergent action. Soap and detergent, they are almost the same thing. They are both cleaning agent. Okay, you might say, sir, then what's the difference between soap and detergent? This is extra info. Detergent is much stronger. Okay, detergent is much stronger. So you use soap to wash your body, right? I don't know lah. Okay, maybe you use a body wash. I don't know, but I use a soap. So you might use a soap to wash your body, but you use detergent to wash your hair. So your shampoo has detergent. Your dish soap, you know, when you wash your plate, the dish soap has detergent. Your washing powder you use to wash your clothes, the one has detergent also. So they are much stronger. Okay, but they are both the same. They are just to, you know, clean away your oil. So that's the difference lah. All right, so as you can see, all these they are fast reaction. They take a short time to finish. Whereas let's look at slow reaction. Okay, slow reaction in this case, they are really slow. For example, rusting. Like I told you already, rusting takes like what? I don't know. If your metal is very not well protected, maybe a few hours. But if your metal is well protected, if it is painted and there's a layer of oil on it, maybe a few days or maybe a few weeks or months, I don't know. But the point is, it is very slow. All right, respiration. This is what you do every moment. Now you are surviving. Okay, you are not dead because you are doing respiration. All right, digestion. This one takes like what? I don't know, 2-3 hours. So quite slow lah. Okay, photosynthesis, same as respiration, also very slow. Formation of stalactite and stalagmite. Stalactite and stalagmite is the, you know, that stone-looking thing in caves. When you go into any cave, it has that stone coming down and the stone coming up, right? The 钟乳石 that thing lah. This thing takes like what? Few thousand years to happen. So it is really, really slow. Okay, so as you can see, slow and fast reaction, they are very obvious. Like fast is like reasonably fast. When it is slow, it is really, really slow. Like rusting, it's really, really slow. Okay, anyway, so this is just the intro, guys. Okay, so my point here being, chemical reaction will change reactant to product. So reactant will decrease, product will increase. If this happens very quickly, it is a fast reaction. If this thing happens very slowly, it is a slow reaction. That's all. Okay, that's all. Nothing difficult yet. Okay, nothing difficult yet. All right, so let's move on. Okay, let's move on. Let's go into our rate of reaction. Oh, here comes the calculation. Okay, I know you guys hate it. Okay, but hey, look at it at a good side. When you have calculation, that means you don't need to write long answers. That means you save your pen ink, you save effort of writing, and you save time. Okay, and you save time. I don't know lah. I'm a very mathematical person lah. For me, maths is a very awesome subject because there's no explanation. Okay, it's just simple calculation and logical assumption. There's no stupid explanation like why is this happening, explain this, explain that, inference this and that, operational definition this and that. I don't know lah. So yeah, are you really good in math? Maybe lor, maybe lor. I'm a big math nerd lah. So that's why I love it. I like things to be direct. Okay, so biology is not really my thing. I mean, I love studying biology, but I hate the explanation. Okay, they give you like 5 points. Explain why does this happen. Walao, that for I don't know lah. I'm not a very ma person. You know, it's ma. Ma means very fussy lah. Okay, like auntie like that lah. I'm not that kind of person lah. So if you like explanation, you are gonna hate this. Okay, girls especially. I don't know what's with girls and calculation. Okay, let me give you an example. Girls, they really, really hate electricity. You remember electricity? During Form 3, Form 2, you learn this V equals to IR thing, right? V is the voltage, I is the current, R is the resistance. When I teach this chapter every year, you can obviously see girls, the face is like dead. They will try to act very interested, No, it's usually the guys listening to me. The girls will just look at me like I'm speaking some foreign language. Okay, I also don't know why. Okay, but then again, very. Okay, do you know why? Do you know why? Okay, you see, okay, girls can be logical too, but let me just tell you, this is why they say guys and girls' brain are wired differently. Guys' brain is very logical. Okay, guys' brain is very logical. In Mandarin, we call 很理性, very logical. Whereas girls' mind is very emotional, 很感性. Okay, this is not being sexist or whatever. Okay, this is survival. Okay, this is survival. Do you know why? Do you know why? You see, since the beginning of times, when human exists, I'm teaching biology already now. Okay, so since the beginning of times, when we are living in caves, what's the job of females? Female is to give birth and produce offspring. Okay, and for you, taking care of a baby, it's a very not rewarding thing to do, right? Because your baby could die halfway, your baby could turn out to be a shitty person. Okay, so this thing is a very non-rewarding job. But for you, you do it out of love. Your mom takes care of you out of love. For no reason, you might turn out to be a shitty person. You might not repay her. You might turn out to be a terrible person. You might be a serial killer. I don't know. But still, she loves you. Okay. If you think about it, is it logical? No. If your mom uses any logic sense, she wouldn't take care of you already. She will throw you into the dustbin. Right, so it's not fit for survival. Whereas guys, why is our brain wired so logically? Because last time, during Paleolithic times, you know what's the function of guys? Our job is to go hunt. Okay, is to go hunt. Is to go hunt for food and bring it back. Hunting requires logic. Okay, you don't use your emotion to talk to animal. Yeah, come back to me lah. Okay, you let me shoot you lah. Okay, so that I can bring you back. No, it doesn't happen that way. So you need logic. This is why after years and years of thousands and thousands of years of evolution, guys, we have logical thinking. Girls, they have emotional thinking. I mean, not everyone is like that, but that's the tendency, 那个倾向. So this is why when this is why girls and guys fight lah. Okay, you see, for example, if let's say, okay, for example, let's say you're a girl, okay, and today you go out and work, you got into a fight with your colleague, you get very sad, you get very upset. Okay, so from your point of view, you want your boyfriend to talk emotional sense to you. Okay, you want him to care about you. Hey baby, how are you feeling? Okay, don't feel sad. Whereas guys, they will look at this in a very logical way. They would say, I think, from my point of view, I think you and your colleague should work this out, because you guys work in the same place, you guys shouldn't fight because it will make things so, but you are not listening any of it. Okay, you will tell your boyfriend, can you shut up? I don't want to hear this thing. I want you to care about me. Okay, so so this is how guys and girls are, we are wired differently lah. So this is not saying that who's wrong or right lah, but this is how our brains are wired differently. So when it comes to science, when it comes to logical stuff, like calculating electricity and all, girls, this is not your thing. Okay, how do I know this? Hey, I study engineering. How come I don't know leh? You know, during when I was studying engineering, engineering is almost 100% calculation. Okay, even there's memorization. Do you know what we memorize? We memorize law. We memorize building law. You know how boring is that? That means in a shopping center, how many exits you should have, how wide the exit must be. Okay, how many fire extinguisher you should put. We memorize this stupid law. So you think you girls want to study that? No. That's why during my engineering years, when I was studying engineering, my whole course, okay, my whole course, my intake was like 150 students, around there lah, 150 to 200 students lah. You know how many girls? You know how many girls? Three. In my whole course, there's only 3 girls. Okay, yes, I study engineering, and it's civil engineering, 土木工程. We study building. We play with sand and cement. Do you think girls will play with cement? Do you think girls will go and play sand with you? No lah. Okay, our whole engineering course is only 3 girls. You think those girls are the girly girls? You are wrong. They are the manly ones. Okay, hey, one of my classmate, she's a girl, she can carry a 50 kilo bag of cement. You can carry. Okay, even guys cannot do that. She's the muscular one. Okay, so you don't think they are girls at all. So I don't know lah. When you study engineering, it's a bit sad lah. Okay, and then every time we sit at the canteen, when we see like business school walk past, like those ACC, because you see ACC is accounting. Accounting is like 70-80% girls. Okay, so every time we see business school walk past, we see ACC student walk past, we look there, wow, 就好咯，你看, okay, grass is so much greener on the other side. Whereas us, you look around us, it's all nerd and geeks. Okay, my engineering friends, I ask them, what you do during your free time? Is either they watch anime, okay, it's either they will play Dota, okay, or they will do some mathematic quiz or Sudoku or something. Okay, I ask them, do you go to dates or whatever? No. Okay, maybe in their life, there's less than 5 female friends in their life. Okay, that is just so sad. Okay, hey, you trust me, next time when you approach an engineering student, you approach an engineering guy, they will panic one, because maybe in their life, they have only spoken to their mom. The only girls they have spoken to is their mom or their sister. That's all. Okay, if you are like an unknown creature to them, you speak to them, they will panic one. Oh, okay, what do I do now? They will start panicking. Okay, I come from engineering school, so I know. Okay, so anyway, let's come back to here. So like I said, this thing requires a lot of logic. Okay, which girls, you tend to think, you tend to figure things out in an emotional way. So logical thing is not really your thing. So but I'll try to make this as simple as I can. Okay, because this thing, I hate to say it lah, in SPM, it's not really a common question. So I don't want to spend so much time here. Later you go SPM, so you lied to me. This thing did not come out. So I'll try to, not do something so difficult here. Okay, anyway, so let's look at rate of reaction. How do we calculate this thing? Okay, so first of all, how do we know a chemical reaction take place? Okay, because you see, sometimes chemical reaction, okay, how do you know rusting take place? Rusting is very slow, right? Okay, rusting takes like years. You just sit there and look at it. No, it's not, you're not going to see anything. Okay, but here are some of the signs, some of the signal that, a chemical reaction happened. There's a change in mass, volume, and concentration of the reactant or product. Okay, maybe the mass decrease or increase, volume decrease or increase, concentration decrease or increase. Okay, there's a change in temperature, pressure, pH value. electrical conductivity, heat conductivity, intensity of color. The best way is by looking at color. You see color, you understand. Okay, because of you see, this is emotional sense again. Girls only care about colors. Okay, you see, when you buy a phone, next time, when you discuss with your boyfriend, hey, B, what phone should I get? Your boyfriend will come to you with a very logical sense. I think you should get an Android. Okay, I think you should get a Samsung S22 because Samsung S22 has this processor. Okay, it's very good for gaming. It has this graphic processor. It has this much of battery. It has this much of RAM, memory, this much of this and that. The megapixel is this and that. Oh, it has 5 camera. Whereas you will say, yeah lah, this phone is very good lah, but they don't have the color I want. See, at the end of the day, when girls buy phone, you only ask one question: this phone got pink, this phone got white, this phone got any color you want. Okay, so I'm not saying all girls are like that lah, but usually that's the question you ask. Okay, this when you want to buy some phone, okay, this. Maybe this is a very lousy phone. Okay, your boyfriend will say, no, this one is no good. Okay, so expensive. But then you say, but this phone got rose gold. You see, rose gold is so cute. Okay, so it's a complete different point of view. So anyway, so what else? Okay, volume and pressure of gas. Okay, height of precipitate. I'm sure you know, like when you see some change, I'm sure you know bubbles, color. Okay, whatever lah. Okay, so let's talk about calculation of rate of reaction. Okay, here comes. Okay, today there's no hard calculation. We are talking about easy calculation. Okay, so how do we calculate rate of reaction? Rate of reaction is the quantity of reactant or product per unit time. That means we take reactant or product, we divide by time. That's all. That's all. Okay, for example, you are selling char kway teow. Okay, you know char kway teow. Okay, let's say you're selling char kway teow. You can make 60 plate of char kway teow in 3 hours. Okay, so what's your rate of reaction? What's your rate of work? How fast do you work? So 60 divided by 3 lor. Okay, because the product divided by 3 hours so per hour you can cook 20 plates of char kway teow. Okay, this is a very lousy example, but I'm just trying to show you. That's your rate of work. Okay, so now this is the easiest way to calculate rate of reaction. But then again, it's not that simple, isn't it? Okay, takkan your question will be like this in SPM. Please calculate the rate of reaction. Yay, end of story. Everybody happy. Then we move on. Of course, it's not like that. Okay, this is SPM. So we have 3 rate of reaction to calculate. Okay, we have 3 rate of reaction. Number 1 is just rate of reaction, or I like to call it total rate of reaction. Okay, the total rate of reaction. And of course, we have average rate of reaction. And then we have instantaneous rate of reaction. So we have 3 rate of reaction. You might say, why need 3 leh? Why cannot just one number搞定 everything leh? Okay, here's the reason why. Okay, let me ask you, if you are a hawker, you are making char kway teow. Okay, let's come back to our char kway teow story. Do you think for the first hour you can make 20 plate of char kway teow? Do you think the second hour you can do that? Okay, maybe. Do you think the 3rd hour, 4th, 5th, 6th hour? Okay, let's just go to the 8th hour. You have been cooking char kway teow for 7 hours. Do you think at the 8th hour you can still make 20 plates per hour? No. You know why? Because you get tired. Because your rate will slow down. Okay, at the beginning you are working at an awesome rate because you're very fresh. But towards the end, you're like, slow down already. Okay, so you see, it's not that just at the end you suddenly slow down. You will slowly, gradually become slower. Right? Maybe first hour you can make 30. Second hour you make 25. Okay. 3rd hour you make 15. See, even slower. And then 5th hour you make 5. And then towards the 6th hour, your hand is so painful you cannot make any more. So you see, rate of reaction is just not one number搞定 everything. No, because the rate just changes every hour. Like I said, if you look at this graph just now, okay, you see, do you see any constant rate here? No, the rate just changes. Okay, maybe first hour, the gradient is this. Okay, your reaction is very fast. And then at the second hour, oh, your rate slower already. Third hour, slower some more. Fourth hour, slower some more. So your rate changes every hour. So to just use one number to represent everything, it doesn't mean anything. Okay, it doesn't mean anything. Just because okay, you have 20, you can make 20 plates per hour. Okay, it's not possible to just say, oh, that means in 8 hours, this auntie can make 160 plates. I mean, theoretically, yes, possible, but the auntie is not a robot. The auntie will get tired eventually. So this 160 plate, it doesn't work that way. Okay, so that's what I'm trying to say. Okay, it's like you learning piano. For example, you learning piano. The first year, you can settle one grade. Okay, do you think it works this way? 1 year, 1 grade. First year learning piano, grade 1. Second year learning piano, grade 2. Third year, grade 3. Fourth year. Wow, if it's that easy, do you think your graph looks like this? No. Okay, that means by the 8th year, you are grade 8, and then by the 9th year, you are diploma already. Wow, you think so easy? You think that 1 year towards the end is the same as 1 year in your beginning, man? No. Because in the beginning, grade 1 is very easy. It doesn't even take 1 year to finish. Whereas your diploma last there, it might take you 3 years. So you see, the rate is very different. When you learning piano, I'm sure that your progression looks like this too. Okay, the first year, wow, you improve very tremendously. Whereas second year, now learning piano, it doesn't feel so fun anymore, because you need to practice so many things. Okay, you need to do that stupid theory. Okay, and then there are so many things you need to study. Okay, and then by the third year and fourth year, your improvement is so little that you just feel very demotivated. Maybe you practice for one whole freaking year, maybe you improve 1%. Okay, that means compared to you see, most pianists are like that. You see, those pianists who has been practicing for 10 years, even the 11th year compared to the 10th year, maybe they improve just that little bit. Okay, maybe you don't even see that because the improvement is like very slow already. So as I say, rate of reaction, they changes over time. This total rate of reaction, it doesn't mean anything. But we are still talking about it. Okay, so this is our simple stuff to. Okay, let's just talk about the total first. Okay, so let's talk about the total rate of reaction. Question number 1. 0.3 gram of magnesium tape reacts completely with excess dilute hydrochloric acid in 30 seconds. Calculate the rate of reaction. Okay, so how do we calculate this? So this is the amount. Okay, and this is the time, right? This one easy peasy, you see, 0.3 divided by 30. So you get 0.01 gram per second. The unit, just be careful. If they give you gram, then you put gram. If they give you cm cube, you put cm cube. If they give you minute, you put minute. If they give you hour, you put hour. So it depends on what they give you. All right, so that means this rate of reaction, the total is 0.01. Like I told you just now, you can make 20 plates of char kway teow in 1 hour. But it doesn't mean anything. This number, it doesn't mean anything. Okay? It's like, okay, average speed. Let me give you another example. Average speed. You know, it's average speed. If you are driving a newer car, for example, if you drive a new Toyota or a new Volkswagen, if your dad does drive a newer car, do you know that the car in the middle, they will show you the average speed? Okay, that means let's say you drive from KL to Penang. Okay, you drive from KL to Penang. And then when you reach Penang, they show you that the average speed is 100 kilometers per hour. Okay, does this number mean anything? No. Okay, because it doesn't mean that from KL you start your car immediately you go 100. Okay, and then 100 all the way until you reach Penang, then you shut down your car. No, it doesn't happen, because in KL when you start your car, your speed is 0. Okay, anyone starts your car immediately you drive? No, you start your car, you warm it up a bit, you just wait there, get 0. And then when you turn up from the car park, it's like 10 or 20 the speed. Okay, and then you drive around your taman. Before you reach highway, you drive maybe 50, 60. And then when you reach highway, maybe you start to speed, maybe you go 120, 130. You see, your speed changes all the time. This number, it doesn't mean anything. Okay, it doesn't mean anything. Then you might say, sir, then why we so 无聊 go and calculate this? This is just part of understanding this. Okay, it's like, oh, you know what this is like? This is like your average your grade prorata, your markup prorata. You know, every year after your final exam, they will tell you your total average mark. Okay, they say your total average is 75 marks. Okay, and you know this number doesn't mean anything because your mathematics could be 100. But your pendidikan seni is like dog shit. Maybe you score 50 because you couldn't draw. Okay, or maybe your maths very good, 100, your science 90. Okay, and then your language, your BM and your BI, wow, mampus, you get 40 or 50 only. But you pull down and up, la chang pu duan, or maybe you reach 75 lor. Does it mean you are averagely good in every subject? No. In this case, your science and maths, you don't need any work already. You are so good. Whereas your language, your English and BM, you need to put a lot of work into it because you suck. Okay, because you only score 50 and 40. So this number, like I said, it doesn't mean anything. Okay, 这个 number 是没有意思的。Okay, we just calculate it for fun. So how do we make this thing more accurate? Okay, like I said, you see, this total rate of reaction, very easy to calculate, very inaccurate. So depends on what you want. If you want it to be more accurate, the more work you need. Okay, let's look at average rate of reaction. This one, wow, so many calculation, so many. But still easy, still not that hard. Okay, but if you want it to be very accurate, this instantaneous is the most accurate one. Also the most work lah. Okay, also the most work lah. You need to draw this stupid line. Okay, you need to draw this tangent. And then you need to do this. Remember what is how do you calculate your gradient? Y2 minus y1 over x2 minus x1. You see? The more work you put, the more accurate something is. Okay, so it's like a good and bad point. It's like a trade-off. Okay, for example, it's like your COVID test. You know your COVID test? The easiest COVID test is the RTK test. You know, you have it at home, the one you speak your saliva one, the one very, very easy to do, but the one is not very accurate. Why? Because you see, when I got COVID, during the first 2 days, no symptom one, I do that test of nothing one. Okay, the test kit doesn't even show me anything. When my symptom is fully out, loss of sense of taste lah, fever lah, sore throat lah, this lah, when all the symptoms come out, you already know this is COVID. Then you do the test, they will show you 2 lines. Need you to say meh, right? The test has no meaning already because I already know. But if you really want accurate, the best way, the most accurate way to do your COVID is to do swab test. Okay, you have to go to the hospital. They have to poke this stupid thing into your mouth, into your nose. Any of you done swab test before? You know how disgusting that thing is. Okay, that cotton bud is this long. They have to put it all the way in. Okay, and then they have to turn. Okay. Oh, Natalie, you did it before, So disgusting. Okay, they have to put it behind, and then they have to turn, and then they have to take it out. And then another hole, another nose hole. Okay, so there's two nose, two holes, They have to do it 2 times, okay. But you know that thing is for sure accurate. Of course, so expensive. One swab test is like what 200 something. You go, government hospital is like 150. Okay, so this test very mafan, very troublesome, but very accurate. Same thing here, you see, very troublesome, but very accurate. This one, the first one, very easy. Okay, at home you also can do, but not accurate. No meaning one. This number no meaning one. Same goes to your home test kit lor. That thing is just for fun one. Okay, then you go to don't know what some let's say you are attending a dinner, whatever wedding dinner, they will ask you to do that saliva test one, right? Just because you are negative doesn't mean you are negative, you know. That thing is not really accurate. It's just to do it to show people that you have no COVID. Okay, but like I said, it's not accurate. Okay, so let's look at our average rate of reaction. Okay, this is more accurate than the upper one. Okay, so let's look at the question. What do they ask? So observe the figure beside. Okay, now there's a graph here. Now more accurately, there's a graph. So calculate the average rate of reaction for the first minute, for the first 2 minutes, for the second minute, for the third minute, for the whole reaction. You see so many numbers to calculate. But the concept is the same. Okay, let's go to the first one. Average rate of reaction for the first minute. Just now, when I calculate this, it's for the whole thing. For the whole thing. Now I don't want whole thing. I just want the first minute. Why is my screen lagging? Okay, for the first minute. Okay, minute per timer. That means if you look at this graph, what is first minute? First minute is 60 seconds. Okay, 60 seconds. That means you draw a line from 60 seconds. Okay, and then you draw a line to your amount, 20. Okay, 20. That means this reaction takes 60 seconds to produce 20 cm of gas. Okay, so this is the amount, right? This is the amount, right? And this is the time, right? So what's our formula again? Amount divided by time, no? So 20 divided by 60. You would get 1/3. So 1/3 is 0.33. So unit is cm cubed per second. You see? So this again, you get a number like up here. You get a number like up here. But this one has more meaning because this number tells me the first minute, the rate is this. Okay, second minute, now the rate is different. Third minute, the rate is different. I separate my graph into 3 parts so that I can know what's the rate of reaction of the first part. Okay, what's the speed of the first part, what's the speed of the second part, and what's the speed of the third part. You see, the more I separate, the more accurate it is. You might say, sir, then can I do 30-second one part? 30 seconds here, 30 seconds, 30 seconds, 30 seconds. Can. You can even do 15 seconds, 15 seconds, 15 seconds. The more you separate, the more accurate it is. You can even do 1 second. Every second you calculate. Gila lah. You have like a few hundred numbers here. But hey, super accurate. The more you split, the more accurate it becomes. It's just like your pi. You know your pi? You know pi? What's the number of pi? 3.142, right? Okay. Do you know pi is unlimited? You know pi is unlimited. You can write your pi number as long as 1,000 numbers. But do you need to? No, because that is redundant and very 多余. No need. Why do you need so long number? But the longer you write, the more accurate it is. At the end of the day, it depends on what you want. How accurate do you want something? Okay, it's like measuring this pencil. Okay, let's say this pencil is 15 cm. How accurate do you want it to be? Do you want it to be 15.1 cm? Or do you want it to be 15.11 cm? Or do you want it to be 15.11111 cm? Do you need so many decimal points? Maybe you do. Maybe you don't. If you don't, then what's the point of doing it? So it depends on what you want. Okay, so this is the first minute. The first minute. Okay, let's look at the first 2 minutes. First 2 minutes means I combine first minute and second minute. I just take the whole 2 minutes for the first part here. So you just do whatever we do, 120 seconds, because 2 minutes, 120 seconds. So you draw a graph up, draw a line up, and go here, 30. So this is the amount. This is the time. Okay, so amount divided by time, 30 divided by 120, you will get 1/4. 1/4. No, I don't have my calculator. I'm just too lazy. So 1/4 should be 0.25. I think So this is cm cubed per second. So you see, this is the first 2 minutes. I combine this thing. But this number also got no meaning. Okay, let's look at the third question. Okay, let's look at the third question. Because what I want second minute. What is second minute? Please don't get confused. First 2 minutes and second minute is totally different meaning. Okay, first 2 minutes means I want from minute 0 to second minute, the whole thing here. Second minute means the end of the first minute to the end of the second minute. Okay, that means 61st second to 120th second. Okay, so don't get confused. This is the whole thing here. This is just the middle part here. Okay, so let's calculate this. So how do you calculate this? Now you need to minus already, because you see, from 60 to 120, the time is 60 seconds. Okay, because 120 minus by 60 is 60 seconds. And then from 20 to 30, okay, is 10. So the amount is 10 and the volume, sorry, not volume, the time is 60. Okay, so amount divided by time, 10 divided by 60, you get 1/6. So 1/6 is 0.167. I think I just sing one just do it quickly. So 0.167 S cm cube per S. Okay, so this is the rate of reaction of the second minute. Okay, so let's compare. Let's compare. Okay, this one has no meaning. The first 2 minutes, no meaning. Let's just ignore this number. Okay, I want you to compare first minute and second minute. Okay, can you see this? First minute, 0.33. Okay, second minute, 0.167. Can you see what's happening now? Can you see what's happening now? The first minute rate of reaction is 0.33. Second minute rate of reaction is 0.167. What does it mean? That means at the beginning, rate of reaction is very fast. Okay, very fast. And then second minute, the thing slow down. Like I said, when you are burning firecracker, okay, at the beginning, very bright, very colorful, very nice. And then towards the end, it starts to slow down, slow down, slow down, slow down. And then at the end, there's no more. Done. Finish burning. So you see, that's why the rate of reaction slow down. So you see, this has more meaning because I know that first minute is faster, second minute is slower. Now if I do the third minute, it's even slower. So this calculation has more meaning than the first one. This 0.01 has no meaning. It doesn't mean anything. It's just a meaningless number. So now let's look at the third minute. Let's look at third minute. So third minute is here. So the third minute from 120 to 180 is 60 here. From 30 to 35 is 5 here. So 5 divided by 60. Okay, this one I need my calculator already. Wait, 5 divided by 60. I'm using my on-screen calculator, it's a bit slow. 0.0833. Like I said, it's even slower. It's even slower. Just now, first minute 0.33, second minute 0.167, third minute 0.0833. Expected lah. Rate of reaction just get slower and slower. Your improvement of your piano skill slower and slower. First year, you can straight away go grade 3 exam. Wow, you thought you are very smart. Okay, and then second year, when you start to get into difficult grades, and then you start to say, wow, why is grade 5 so hard? Okay, and then when you start to go third year, wow, even grade 6, you feel like dying already. So as you progress more and more, your progression starts to slow down. Okay, you get what I'm trying to say? So at the end here, the rate is 0. Here is like 0, no, done. Okay, everything is done, finished already. So as I said, these numbers, 3 numbers, they are more accurate than this 1 number. Okay, so next week, okay, I think I'm going to end here today. Next week, we shall go for every second. Just now it's every minute. Next week, we will go for every second. This is a lot of work. Okay, you need to draw this line and this and that. Okay, so I shall torture you next week. This week is just, like I said, it's just a warm-up. Just a appetizer. Okay, next week is where the main course comes. Okay, so I hope you learned something new today. Okay, it's just a very simple calculation and simple concept. Okay, I shall continue this next week. So hope you have a happy Wednesday. I will see you again next week. All right, so take care, everyone. Okay, thank you. See you and bye-bye.